Okay, on Monday I've given a set of tutorial lah, get from YouTube about 29 tutorial. If you have a look, Nadrul,
Not yet.
not yet And anyone have a
Uh,
look? Anyone have a look tutorial in you future? Anyone have just to make sure you get the tutorial so that you can to make sure you can access the tutorial and access tutorial in my course file saja in you future. Okay, I think you can take a look later on, or I will repeat again in the during the lecture. Okay, let us have a look. This one, I think these are all the basics. Rectangular. Hmm. So analysis of motion of particle. Some of this tutorial is well, you can go through at your own time. Let me have a scroll for the slide. Mm, a student should be able to explain the concept of distance, position, velocity, and acceleration of particle in one-dimensional and two-dimensional, and then determine absolute relative distance, position, displacement, velocity, and acceleration of particle in one-dimensional and two-dimensional using xy. This is Cartesian, and t. This is what normal and tangential, r and theta. So these are the famous one, or the popular one will be, or in or I can say that will be mostly used in our course. Okay, I think for this motion of a single particle in a straight in a plane, move along the single particle, rectilinear, curvilinear. Then the motion of several particles in the plane. That means there are more than one particle. And also this one you can have a look, you can read through. And then we have here rectangular XYZ. I think for this one I've explained a lot in the previous lecture and also in your tutorial. So if you can't hear me, please let me know. Okay, rectilinear motion. Okay, polar. What is this? So rectilinear motion is given here in three conditions. A equals to 0, A equals to constant, A equals to variable lah. So maybe I can touch this one here a little bit. Let me see whether we can write it on my this is called wacom device, and then have a look here. Uniform acceleration, A equal to 0. This is under rectilinear motion. Remember, rectilinear motion. We will use this one a lot lah. In any motion that is moving in a straight line. So later on, by doing example, you will see that we will use a lot this equation. Or you can write down this one on your formula sheet. I hope everyone by now should have their own formula sheet so that you can refer quickly during answering any exam question or final question. So A equals to constant. This is the one that mostly we use. So you have to memorize these three equation, or you have to understand where and when to apply this equation. I think you have three here, one, two, and three. Tangential component, normal and tangential. I think we have also looked at this one a lot. Also, these are the formula. You should have your this formula written in your formula sheet. Also, these are the case where acceleration as a function of time. That means your acceleration become a variable lah. For example, f equals to ma. I try to write it down here slowly. Uh, I think my computer or my tablet is not very smooth. You see, it's quite hard for me to write down smoothly, but I will try. So last time you found that the f equals to ma, maybe given to you have a certain value of f equals to constant. F is constant when what? Anyone? Nazrul, is constant. This case betul. Nazrul. Ah,
Yeah.
F constant kan? Kat sini.
Ah.
Okay, kalau A berubah, now you have a A changing.
Mm-hmm.
A changing F. You have to do some integration to A betul.
Integration, eh?
Yep. Or yep. That means A is changing against time lah. So
Uh-huh.
dv dt. So A dalam sebutan T lah. Betul. So F is no longer constant where you have to do some integration towards A.
Integration.
Betul.
Ah.
So these are the case when you will see in the question the value of A, you need to do some integration or differentiation lah.
Integration.
Bila nilai A is no longer constant. Compared to this one, these are the major what? These are the major difference between this equation and this equation lah. In this case, A is constant. For example, you have projectile and or any motion and a dependent motion. I think you have not yet have a look because last week you have on Thursday you have holiday. But anyway, I prepared the lecture, but I think cannot be uploaded in near future. I think on this Thursday, I will make an announcement. Where is the link for the previous week lecture? So the video is ready, but I have problem to upload it in the future. Maybe the file is too big. So that what I'm trying to say here. So you have to in the question when
Sir,
uh,
sir. All
saya
the tutorials and lecture on your YouTube channel, eh?
no. Now it's mix because
Oh, mix with another
because
channel.
I try to put in new feature, but
Mm-hmm.
the big file I think cannot be uploaded. So I try to find a way whether I don't know whether my system problem, web problem, or the file is too big.
Oh,
Because one of the lecture I can upload, the other lecture cannot be uploaded. So I need to find a way So last time the best way is to put in the YouTube. Mm, give me some time to figure out how. If
Alright.
worst come to worst, then I need to upload in the YouTube lah. Because
Alright.
in future you can easily access. You see, in your future you can easily access the content, but maybe maybe your future cannot upload a file that is too big, so we have to find another way. The small file so far is okay. Mm. Okay. What I'm trying to say here, there will be a question for sure in your test or in your final that you need to use this equation. Uh, but you need to really careful which equation to be used. So we have F equals to ma here, as I given here. Just to demonstrate when to use this for integration or differentiation. Another thing is that if you are familiar when there's a war between, okay, we right here, okay, we have space here. So this is again, I need to find a way how to solve this problem. I need to find a better device so that I can explain clearly. But now we have just to use whatever we have. Okay, I think here you have a is a variable, so you don't have to integrate the mass, betul? Am I correct? Anyone?
Yes.
Uh,
Mass is concern.
mass is constant. But if you still remember, or you can see any movie or any YouTube channel or a short movie, whatever. You see a rocket or a scud
Mm-hmm.
when they are when they are launched in the air. The mass is what? What happened to the
Tak
mass?
berubah.
Huh?
Tak berubah macam tu ke?
No, no, rocket in
Oh,
a,
rocket.
in a rocket rocket dia are apa? Hmm, I put
Dia
here
dia,
as uh,
dia dijatuhkan benda.
dia this is a scud where apa? You have apa ni, biasa dia ada ni lah, sama ada liquid oxygen or apa. Kalau roket ni yang macam ni dia ada ni, dia ada belerang lah. First dia akan bakar belerang,
Mm-hmm.
then bukan to take over to overcome the gravitational force. So belerang tu macam yang mercun tu lah, dia akan apa, give a very very powerful apa, a force or thrust, so that the rocket can overcome the gravitational force kan. And then the second part of combustion, you have oxygen, liquid oxygen. The when they are in the air dia akan apa, release dia punya apa, akan release dia punya oxygen lah. Okay, so what happened in this case? What happened to the mass? Mass is what?
Kurang.
Decrease lah.
A mass decrease. In other words, mass is changing with time. So if you want to get the thrust, so you have to integrate the mass. Huh?
Mm-hmm.
Okay, understand? Or
Yes.
or you can
Understood.
write down like this lah. Mass, I think a dvdt, and you have to multiply with, I don't know, maybe you have to perform some integration in term of a also. In a simple word, it will be like this lah. Maybe dvdt, so this is dmdt lah. So you see, when to apply, this is very important to get so that you do not confuse when to integrate, when to differentiate. So and in this case, I give an example of a rocket where during the rocket is being launched or the SCAT, this is SCAT or apa, kita panggil apa ni? Dia SCAT ataupun kita panggil ni, this is a bomb, kita panggil apa dulu ni? I forgot lah. I think one of them call it SCAT lah. This is during the war in Iraq. They use SCAT, this launcher. When they launch, the mass is changing due to the uh, burning of the fuel. So to get the thrust is no longer constant. So also the mass of the object is no longer constant. So you have to do some differentiation and integration. Okay, we move further here. Okay, tangential and normal coordinate cylindrical rectangular. This is very good note. That's why you need to spend your time to go through this formula, this tutorial again. But again, this we have discussed a lot this part in the during the lecture. Again, you have to put this formula in your notes. This formula, so you need to understand what are the term here. This are our scope, because we are no longer face to face lecture, so you need to know which scope. And then they ask me to use a Beer and Johnston. I will Beer and Johnston using a textbook. In the textbook, there are a lot of things, lot of topic being covered, a lot of angle. But I think during this in this tutorial, these are our scope mainly. So by following the lecture and the tutorial, you know which part that you need to full understand, and which part which are left, which is not in our UATM syllabus lah for this course. Okay, let's do 102. This one, a motorcycle is traveling east at a constant speed, 100 kilometer. What is the velocity of the motorcycle? Huh? I have to do some calculation lah. Constant speed. So what are the equations to be used? This one is okay. What is this? Also, there's also an exercise on this in my tutorial. So you can try to do at your own dekat tutorial lah. In the U future, Syahmi Asbani. Syahmi,
Ya saya, ya saya.
ada buka dekat U future tak? You ada buka dekat U future?
Buka tadi tapi tak ada.
Tutorial tu tak ada dekat saya punya course content lah.
Dekat group content.
Course content. Under my folder lah. Okay, I cuba all of you try to open under my folder. Try to have, there is a lot of tutorial on this topic. The tutorial I have taken from YouTube because they have they have better explanation with a proper device. So I try to find to find the same device so that we can have a lecture up to that level of standard lah. So for now,
Ada video je.
video betul.
Ada PDF. Ada video PDF untuk yang kita ajar ni.
Ada video YouTube kan, betul?
Betul ada video.
Betul.
Ada banyak 29 video
Betul-betul lah, suara you tak clear. Don't know whether your line or my line.
Ada 29 video ni.
Betul, betul, betul. 29 video tu, 29 short movie or short clip that are related to our course for this chapter. So that will help you a lot to understand. Maybe during this tutorial, you can it's very limited device for me to write. Because saya punya pen ni pun dia respon lambat lah.
Doktor,
Ya,
apa dapat file yang doktor share ni
tak ni,
PDF ni?
tak clear. Tak clear dia cakap. Hello.
Hello.
Okay, dengar.
Kat mana doktor nak ambil ni PDF ni?
PDF ni I think in the
Ya.
first few announcement ada. I think first atau second announcement dah ada PDF ni. File ni. You tengok dekat attachment. Lah.
Punishment
Dekat attachment. That's why you have to form a group. I don't know whether you ada group WhatsApp tak dengan saya. Kalau tak ada, you
Ada,
form.
ada.
Kalau tak ada, you form. Dan kalau dah ada, you boleh tanya dekat group WhatsApp. Jadi I can guide you. I can guide you for the tutorial because sometimes kita buat online, sometimes kita buat I send a video depending on the system that we have. Kadang-kadang saya punya line internet tak boleh up. Jadi saya kena pakai video. So far okay. We continue. Is there? In this example, you see, dia minta you ambil datum lah. Kalau you dah buat ni, biasa dia akan ambil panjang tali. Anyway, I will explain. Biasa saya ambil datum kat sini, dekat pulley, so that you can you can form an equation. Sama juga sini, dekat sini pulley. Sampai sama level dengan pulley. Of course, here also, you tengok dia ambil dekat pulley. Kita tak ambil dekat blok. Kalau kita ambil dekat blok, nanti you nak buat panjang tali ni. So, this is your datum. So, in this case, this is your SA. Again, this is your datum. Bukan kita ambil panjang tali. Tengok ada exercise tak? Look at any exercise. You can read through this one. Ini kena baca. Different kinematic and kinetic. Tapi dia tak tanya lah. Tapi mungkin tanya dalam ni kot. Dalam kalau final tu mungkin dalam bahagian A. Tapi di SEM because kita buat open book. So maybe question might be slightly difficult. Not like the previous SEM. So you have to prepare all the material lah. Kinematics, kinetic.
Betul.
Apa
Ni yang dekat announcement kan. Latest tu saya cek yang mana tu dia tunjukkan yang bulan ni aja. Sebab yang lantar tu bulan lepas tak boleh tengok.
Tak clear. Terputus punya suara. You have to type down in the chat. Try to type down in the chat.
Ni sir.
Clear.
Sir?
Clear suara you.
Dekat announcement.
Okay.
Announcement dekat yang group tu.
Okay.
Ada announcement yang baru yang dua yang latest. Yang announcement yang sebelum-sebelum ni dah tak ada.
Tak ada. Hilang.
Hilang.
Nanti
Yang semalam punya pun dah tak ada.
You complain dekat ni group WhatsApp, nanti saya rectify. Saya tak tahu sebab apa.
Okay.
So saya nak kena communicate dengan you, dan kita kena ada group WhatsApp untuk untuk communicate. Because problem macam ni lah. Saya nak kena I need to know Dan saya check dengan
Oh, okay.
sama ada sistem ke apa, tak tahu lah. Ini sistem lah ni. Okay.
Okay.
Nanti you masukkan dalam grup WhatsApp, nanti saya akan tengok.
Saya bina ayat.
Okay. Boleh bezakan kinetik. Bukan you first time susah sikit lah. Kalau macam saya dah selalu ni, kinematik ni dia ada apa. Okay, I put you see the device yang saya pakai ni dia tak berapa smooth ataupun dia tak compatible dengan saya punya komputer. You see saya tak boleh tulis. Ada problem untuk boleh tulis. I'm trying to write here kinematics SVA saja. Kalau kinetic kita ada force, kita tambah force lah. SVA. Itu beza dia. Kalau kinematik kita study, kan, displacement, velocity, acceleration saja, tidak ada force lah. Untuk kinetic dia tambah force lah. So dalam dynamic ni tak ada lain lah. Okay. Dalam dynamic, you belajar sampai apa, level mana pun, 3 benda ni dia tanya. Betul. These are the 3 things that we are discussing. And kadang-kadang ada tambah satu kau mungkin force lah. 4 benda je. Tapi dia, walaupun 4 benda dia killer lah. Betul. The killer subject because of the confusion. Walaupun you tahu tapi given a situation, walaupun you tahu formula, kalau you don't know where and when to apply, then that will will cause a great problem to you, especially when you answering a question. For example yang kita discuss sebelum ni kan, nanti ni. Contoh soalan ialah apa ni, the value of A is a variable lah. Variable A depend a certain other value, so A is no longer constant, so you cannot use this formula lah. So some student they tend to become confused, so dia pakai formula untuk apa? Constant acceleration. They integrate. So basically, the student is confused in applying the equation. So we move further. Ini tulis coordinate apa ni? Tak apalah, ini baca. Tak faham ni boleh tanya dalam ni lah, dalam apa ni? You can ask me in the WhatsApp. Okay, look here, AKV. What happened here is moving. We can see here, look at the diagram, we have a plunger. So velocity, V not moving to the right. A equals to minus KV. The velocity V is no longer constant. So in this case, apa ni? V is a variable lah. Yeah. Without looking at the question, we can see the system. The piston moves to the right with apa ni? With a variable value of A. So in this question, there will involve some differentiation or integration, but mostly integration. And buat dia bagi A mesti dia tanya ni. Takkan you nak kalau dia bagi acceleration A, takkan you nak differentiate lagi. Betul. You have here S V A. As you goes down, you have to what? Apa ni? Differentiate betul. As you go up, this is D. You have to do some integration. So that's why you see in the solution, there involve some integration because you takkan you nak differentiate lagi. Dia bagi given A kalau you differentiate lagi dA dt lah. Belum jumpa ni jadi kita tak differentiate lagi lah. So basically if you want to ni, you have to move the question will ask you for V and finally S ataupun X lah. Displacement. So this is involve integration. So A dV dt, V dx dt, A V dx dt. So you rearrange this equation, so you get A V dx dt. So you integrate this one. You integrate A dV dt to find Vt. So here, you rearrange the equation. A dV dt minus 2A equals to minus kV. But at the same time, A equals to dV dt, so you move where K is constant. I think you can rearrange the equation, and you can rearrange this equation, so you get in this form dV divided by V. So in this case, V moving here in this position, and then K you left there, then you integrate both sides. So dt pergi atas lah. The place for V and T interchange, then you can integrate both sides, then you have the answer in this case. Again, you have to do some integration to find xt. You see here, to find xt, as we mentioned here, you see here we have to do some integration to find x, get another integration, and again finally you get the answer in terms of x, which is the movement of the object. So you have V dalam sebutan T, V against T, then you have a certain graph depend on this equation, and then the other one you have a graph which is x against T. You have a graph, so these are the equation. You still remember we have learned this one before. Okay, we look at this again, this one. Either they involve some integration or we can use the formula straight away. Not sure. Again, the variable lah. So the acceleration is given by this one, so there will involve again integration or differentiation. But you see here, car A move along straight path with the initial velocity of 50 meters per second and the acceleration with the left part concentration. So you can this is a mix the motion you have straight line at a constant acceleration. This is a good example where car A have a variable acceleration, car B has a constant acceleration. So here V dx dt equals to 20 for car B and you can do the math for this one lah. This one. This one actually you should have apa ni during the lecture, but this is one of the famous and easy question because very straightforward. Let us have a discussion on this. And, look here, Nazrul. Oh Nazrul Nazrul.
Ya saya. Ya saya.
Pernah jumpa exercise ni? Pernah buat? Tak pernah? Ataupun this one the first time?
Mungkin pernah buat time asasi tak apa ingat lah.
Boleh faham tak yang ni?
Ke tak pernah.
Tak boleh faham.
Tak ada.
What we are doing here actually, the first you ada dua equation Satu panjang tali, total length of the rope. Look at here, dia punya datum ni. Macam saya buat tadi kan, dia ambil dekat puli baru dia boleh dapat total length of the rope. So XA panjang sini ke sini. You can see here. XA from block A to the pulley. And then what is XB from the pulley. Then you have XD. Kita tengok panjang tali ni. Total length of the cable. Kita panggil rope kita cable lah. Total length of the cable which is XA. Yang atas ni dia constant tu kita ignore. Then we move down. This is not constant but you have to express in terms of what? 2XD yeah. This is called XD. So you have 2XD. And then another one which is XB betul. Boleh faham Nazrul? Nama itu orang dia keluar kat sini.
Nampak ada idea sikit.
Ada sikit je.
Ada idea sikit.
Tak boleh faham
Saya tak berapa jelas sangat. Saya kena tengok sebab skrin nampak kecil.
Kita buat kecil Kenapa
Tak apa.
You have to zoom kecil Dia pakai handphone ke PC?
Boleh zoom. Boleh zoom.
You zoom.
Okay.
So both both you and me have to use what the advantage of the technology.
Okay.
For the time being For the time being kita kena we have to
Tak perasan dia boleh zoom
we have to upgrade ourselves kan. So saya pun cuba that's why I mentioned to you, saya pun cuba tengok whatever latest device available in the market so that the lecture can be done very smoothly. Now I cannot do lecture very smoothly because of some restriction of the gadget. So I will find a way how to improve the lecture so that we can you can have a better understanding. So this is a total length of the rope. So you have this equation. Then first time you do a differentiation, you get velocity here. And second time you get this is the first time you get velocity. And the second time you get acceleration when you integrate this equation Okay, that is the equation. Since this is a motion in a straight line with a constant acceleration, so you boleh pakai these are the famous equation. You boleh pakai S equals to U half at squared. So tengok saya punya tulisan ni agak slow dia keluar. V squared equals to U squared plus 2AS. I cannot write it there. Dia padam last time saya try this okay, last time I try this one is okay, but now I think there's something wrong with the apa? Dia not compatible lah. Dia ada jerking ya. V squared equals to not very smooth. Another one is V equals to U plus 80 eh. I think it's given here at the top of this apa? Mana tadi? The top of the slide. Got it. Let me try to find where is the equation. This one. So these are the equation. Constant acceleration. And I put now in the red circle. Constant acceleration. Okay. So these are the two formula you need to apply. So two main formula. One is the total length of the cable. In this case, and constant acceleration. So this is a straightforward problem, and a very straightforward how to solve. So this one again another example. What they are looking here, A, B. A, B relative to A. Velocity is very straightforward. So again, if you still remember, this is dynamics. Dia ada tiga saja. S, V, A. In this case, they are asking for velocity A, and this one is B, and the B is asking for acceleration. Velocity is very straightforward, but you have to look at the position. Mana position? A. You try to have a rate by moving. Again, I repeat here. The rest is normal, tangential, tak nampak ni. I will zoom. Let me see. I try to zoom. Yeah. Okay, nampak. Dua.
Nampak.
You boleh ni. Okay, I want to explain this basic concept. What does this mean so that you do not confuse? This is called A, B relative to what?
A.
B relative to A, ataupun yang boleh tulis B dekat depan. B dekat depan, A dekat belakang eh.
Oh.
This is equals to but here also you have AB eh. AB ni dia relative tu apa ni? AB ni dia ada O kat belakang ni.
Initial.
Yes, initial. So this is actually AB minus
AO.
AO.
A0.
A0, A0. So, biasanya ni kosong lah, betul? Your reference point. So, using this theory, you can expand to here to understand what is AB, what is this meaning lah, what is the meaning of this. So, you have to write it down correctly because we will need to use this one a lot lah. So in this case, how to say it or pronounce it? This is AB as acceleration of B relative to A. Yeah? Acceleration of B relative to A. In this case here, acceleration of B relative to O. So this is normally is written as A B. Yeah. So what so the term on the left here O is your fixed point. That means a person at O. This is O. Is looking at BN. So that's why it's mean here. And here a person at A. Maybe here is point A. Here is point B. A person at A is looking at point B. So you have here point O. Okay, any question? Any question? We have to stop here. This is projectile. Hopefully you can go through. This week we enter a new chapter. I think this week kinetic of particle, Newton's second law. But I will pass you the lecture in the. I will try to find. You look at the announcement. If you did not get, we can communicate via WhatsApp or by next lecture on the Thursday. Yeah. Okay. Any question?
So, the notes
Yes.
nak dapat kat mana?
Which one?
Kalau announcement tu yang sekarang yang ni. Yang tutorial.